You know that feeling, just before you fall asleep, when the whole world goes very quiet, when the sounds of the day drift away and your thoughts start to slow down and everything feels soft and still and far away. That is a little bit what space is like. All of it. All of the time. Space is the quietest place there is. There is no wind in space, no rustling, no humming. Sound cannot travel there at all because there is nothing for it to travel through. If you were floating out in space, very, very far from here, and you clapped your hands together, you would not hear a single thing. Your hands would meet in total silence, and the ripple of that sound would go nowhere at all and disappear. Isn't that funny to think about? Clapping in complete silence. Like a dream where the sound has been gently turned all the way down. Space is also the darkest place. Not the dark of your bedroom, where there is always a little light sneaking under the door, or the glow of something outside the window. Real space dark is something else entirely. In the very furthest, emptiest parts of space, between the galaxies, between all the stars, there is a darkness so complete and so deep and so still that it is almost impossible to imagine. Almost. But let us try. Close your eyes for a moment, or keep them soft and half-closed, whichever feels right. And imagine you are floating. Not falling, just floating. Very gently, as if the world has become perfectly weightless. You are warm and comfortable, and you are moving very, very slowly through the quietest place that exists. Around you, far away, are stars. Thousands of them, millions of them. They do not look very big from here because you are so very far away. They look like small, bright points, like tiny holes poked through a dark blanket, letting through a little glow from something bright on the other side. And you float, very gently, in the quiet. And you look at the stars. Now. Among all of those stars, if you look very carefully, there are certain places where there are no stars at all. A little gap in the brightness. A small patch of nothing, of darkness, a little deeper than the rest. And that, very gently, is where our story tonight is going. Because in some of those dark patches, something wonderful is hiding. Something called a black hole. A black hole is not a hole in the way you might imagine one. It is not a hole in the ground, or a gap in a fence, or a hollow in a tree. It is not a hole you could fall into the way you fall into a dream. It is something that sounds like a hole, but is actually something closer to the opposite. It is not emptiness. It is the most crowded, most packed, most squeezed together place in all of space. Let us think about that for a moment, because it is one of the most surprising things about black holes, and it is worth letting the idea settle slowly, like a leaf drifting down through still water. You know what a star is, don't you? A star is a big ball of gas, mostly a gas called hydrogen. And it is incredibly hot and incredibly bright, and it has been burning for a very, very long time. Our own sun is a star. Our sun has been burning for about 4.5 billion years, and it will keep burning for about another 5 billion years after that. So, a star is not something that goes out quickly. Stars are patient. Stars last a very long time. But eventually, after billions and billions of years, a star starts to run low on fuel. And when that happens, something interesting begins. A very large star, much bigger than our sun, much bigger than you can easily picture. When it runs out of fuel after its billions of years of shining, it collapses. All of that gas, all of that matter, that enormous ball of stuff that has been hanging in space, starts to fall inward. It falls toward its own middle. Gravity pulls it all in, and it squeezes and squeezes and gets smaller and smaller and denser and denser and denser. And then, very suddenly, in the life of a star, all of that matter is squeezed into something almost unimaginably small. Not the size of a city, not the size of a house, not the size of a marble. Smaller. Sometimes much, much smaller. All of that enormous star squeezed into something tiny. But still with all the same gravity, all the same pull. And that is where the black hole begins. Now, gravity is something you know very well, even if you have never thought about it by name. Gravity is what keeps you in your bed right now. It is what keeps your blanket on top of you, and keeps your pillow where it is, and keeps the house in its place. Gravity is what pulls everything toward everything else. The bigger and heavier something is, the stronger its pull. When you hold a ball and let it go, it falls down. That is gravity. The Earth is very heavy, very massive, and it pulls the ball toward it, and the ball falls. Now, the Sun is much more massive than the Earth, much heavier. Its gravity is so strong that even though we are 150 million kilometers away from it, 150 million, which is a number so big it is quite hard to think about while you are getting sleepy. even from all that distance away. The Earth is caught in the sun's pull and goes around and around it year after year, endlessly. And a black hole has even more gravity than that, much more, because all of that mass, all of that weight, has been squeezed into such a small space. And gravity does something very interesting when it gets that strong. It pulls on light. Now, light is something we tend to think of as fast. And it is. Light is the fastest thing in the universe. Nothing travels faster. The light from the lamp in your room reaches your eyes before you even notice it moving. Light from the sun takes about 8 minutes to reach us, and the sun is 150 million kilometers away. 8 minutes for 150 million kilometers. That is very, very fast. And yet, a black hole's gravity is so strong that it can pull on even that. Even light, moving at its full extraordinary speed, cannot escape if it gets too close to a black hole. Isn't that something to think about? Imagine light traveling faster than anything and then meeting something it simply cannot get past. Meeting a pull so strong that even all of its speed is not enough. Light goes in and light does not come out. And because light does not come out, we cannot see the black hole. It is invisible in a very complete way. Not invisible like something hidden behind a curtain where you could peek around the edge. Invisible because there is no light there to see. Just dark. Just quiet. Just the deep, still dark. And that is why we call it a black hole. There is a boundary around a black hole. Scientists have a name for it, a long, careful name that sounds like it belongs in a very serious book. But the simplest way to think of it is as a point of no return. A line, an invisible circle in space, where if you cross it, you cannot come back. Not because anything pushes you, not because there is a door or a wall, just because past that point, the pull is too strong, and forward is the only direction that exists. This boundary has a name. It is called the event horizon. Horizon is a lovely word. You know what a horizon is? It is the line at the edge of what you can see. When you look out at the sea or across a wide, flat field, the horizon is where the sky meets the ground, far away, where your eyes cannot quite reach. And an event horizon is something like that. It is the edge of what anyone outside the black hole can ever see or know about. Past it, events happen in a place we cannot observe. Past it, things happen that we will never get to find out about. It is like a secret. A very, very permanent secret. Can you imagine what it might be like drifting through space, approaching a black hole from far away? From a long distance, you might not even notice it. It is dark, remember. You cannot see it. But you might notice that the stars around it look a little strange, a little bent. Because light bends around a black hole. The gravity is so strong that even the light from stars behind it gets pulled slightly, curves around the edges. So you see the stars around a black hole in strange places, stretched and curved and multiplied, like looking at a reflection in a very wobbly mirror. This bending of light has a name too: gravitational lensing. But the important thing is just that it is strange and beautiful and a little dreamlike. Stars appearing where they should not, curved around an invisible dark center. If you were watching from very, very far away, safely far, comfortably far, floating in your warm and quiet corner of space, you might see a dark shadow in the middle, with a faint glow of light and gas all around it, bent into a ring. A glowing ring of light around a circle of absolute dark. Scientists have actually seen this. In the year 2019, a group of scientists from all around the world worked together for a very long time, and they took a picture of a black hole for the very first time. A real picture. And it looked almost exactly like that. A blurry orange glow, like a ring of soft light, with a deep, dark shadow in the middle. The scientists were very excited. You might imagine that scientists, after working for years and years toward something, would be very loud and jumping around when it finally happened. And apparently some of them were. They were very, very pleased. And isn't it wonderful to think that all of that effort, scientists all around the world, telescopes on different continents, years and years of careful work, all of it to take one blurry picture of something very, very far away. Because the knowing mattered that much. Because the looking, even at something you cannot fully see, still feels important. Now, there are different sizes of black hole. This might surprise you, because it surprised a lot of people when they first heard it. There are small black holes. Small for space, anyway, which means they might still be the mass of a few suns squeezed together, just squeezed into a very tiny space. These come from the collapse of single large stars. And then there are the enormous ones. The ones that make even astronomers go very quiet and look thoughtful. These are called supermassive black holes, and they live at the centers of galaxies, at the very middle of enormous collections of billions of stars, sitting there quietly for billions of years. Our own galaxy, the Milky Way, the galaxy that our Sun and our Earth are a part of, has a supermassive black hole right at its center. It is called Sagittarius. Ah, which is pronounced Sagittarius A star, and it is about 4 million times more massive than our Sun. 4 million suns, all squeezed together. Sitting at the center of our galaxy, very far away from us, very quietly, having been there for a very long time. We are quite safe, of course. We are 26,000 light years from the center of our galaxy. "26,000 light years, which means even light, traveling at its full extraordinary speed, would take 26,000 years to get there. We are very, very far away. So there is nothing to worry about. We are just floating gently out here in a quiet corner of the Milky Way, looking toward the center, the way you might look at a distant city from a hillside at night, seeing only the soft glow of it, too far away to hear a single sound. One of the most curious things about black holes, and there are many curious things, so we will drift through them slowly, one by one, without hurrying, is what happens to time near one. Time is something we usually take for granted. A minute is a minute. An hour is an hour. An hour is an hour. The clock ticks at the same pace for everyone, everywhere. It feels that way. But actually, time moves differently depending on how strong the gravity is. This sounds like something from a story, but it is true. It is something that scientists discovered and have tested and found to be accurate. Closer to something very massive, something with very strong gravity. Time passes more slowly, not by much for most things we experience. But near a black hole, the difference would be extraordinary. If you were in a spaceship hovering very close to a black hole, not close enough to cross the event horizon, but very close, time would be passing very slowly for you compared to someone watching from far away. You might experience 1 hour while they experienced many, many years. Imagine that. Floating near a black hole for what feels to you like an afternoon, and then returning to discover that decades have passed for everyone else. The world changed. Years went by. People grew older and the world moved on, while you were just hovering there, feeling like barely any time had passed at all. It is a thought that can make your mind go very still and quiet if you let it, like a koan or a puzzle with no sharp edges. Just a soft, floating strangeness. Scientists call this time dilation. And it is real. It has even been measured very carefully right here on Earth, where clocks on high mountains tick ever so slightly faster than clocks at sea level because gravity is very slightly weaker up high. The difference is tiny, barely noticeable. But it is there. Time and gravity are connected in ways that are deep and quiet and still surprising, even to the people who study them. Here is another thing that is strange and lovely about black holes. They are not entirely silent. Or rather, they are not entirely invisible, if you know how to look. Even though light cannot escape from inside a black hole, the space just outside the event horizon can be very busy. Gas and dust and bits of matter floating in space sometimes get pulled toward a black hole, the way water spirals slowly toward a drain. And as all of that material swirls around and around, it gets very hot. It bumps into itself, it compresses, and it glows. The glowing ring of material around a black hole is called an accretion disk, and in very active black holes it can be extraordinarily bright, brighter than entire galaxies. A single black hole, eating gas and dust, can outshine 100 billion stars. These very active, very bright black holes have a name: quasars. And quasars are some of the brightest things in the entire universe. They can be seen from billions of light years away. When we look at the very distant universe, the very far edges of what our telescopes can see, many of the brightest things we find are quasars. Ancient black holes, eating and shining from so long ago that the light we see left them before our Earth even existed. The light has been traveling for billions of years to reach us. Billions of years crossing the quiet dark and then arriving here at our telescopes tonight to tell us something about the very early universe. There is something deeply peaceful about that if you let it settle. All of that light, patient as anything, traveling through the quiet dark for longer than you can comfortably imagine, and arriving. Still arriving. Still telling its story. People sometimes ask, and it is a very reasonable thing to wonder about, especially when you are getting drowsy and your thoughts are getting soft and loose. What would happen if you fell into a black hole? This is a question scientists have thought about quite a lot, and the answer is interesting and also slightly funny in a gentle way. From far away, from someone watching safely from a distance, something very strange would appear to happen. Because time moves so differently near the event horizon, the person watching from far away would see you slow down, not a little, enormously. As you got closer and closer to the event horizon, you would appear to move more and more slowly, like a very old film being played at slower and slower speed. And then, right at the horizon, you would appear to stop completely. Frozen. A dark image fading slowly as the light around you drifted away. You would never appear to cross it from the outside. You would just seem to hang there forever at the very edge. And yet, from your own experience, drifting inward in the quiet, You might not notice anything dramatic at all. You would cross the event horizon without any fanfare. No door slamming, no dramatic flash, nothing to mark the moment. Just more falling into more dark. And then, eventually, deeper in, gravity would become so strong that it would be felt differently on different parts of you, slightly stronger on one side than the other. And things would become more unusual. But that is perhaps a thought for another night. The point is that two different observers see two completely different things. You experience one story. The person watching sees another. Both are true. Both describe the same event from different places, and they do not agree, and both are correct. Isn't that a remarkable thing? That the same event, witnessed from two different places, can look so completely different, and both versions can be right? It is a good thing to remember, even outside of space, that what something looks like depends enormously on where you are standing. Black holes have been known about, at least as an idea, for a surprisingly long time. A man named John Michell in England in the year 1783 sat down and thought very carefully about gravity and light, and wrote about what he called dark stars. Objects so massive that even light could not escape them. He was thinking about black holes more than 200 years ago, even though he had none of the mathematics or telescopes that scientists have now. And then, much later, a man named Albert Einstein wrote down a set of ideas about gravity and space and time in the year 1915, and those ideas predicted that black holes should exist, though Einstein himself was not entirely sure they really would. He found the idea almost too strange to believe. But then, as time went on and more mathematics was done, and then telescopes were built that could see things no human eye could see, light invisible to us, radio waves, X-rays, slowly the evidence gathered. And gathered. And gathered. Until the year 1971, when scientists found the first very strong evidence for a real black hole. And then more, and more, and more. And in 2019, that photograph, that blurry orange ring, more than 200 years from John Michell quietly writing his thoughts in England, to a real image of a real black hole, built by a whole world of scientists working together. Some ideas need a very long time to be seen. Some things have to wait in the dark for a long time before the light reaches them. And still they are there, real and patient, all along. There is a question that comes up sometimes about whether black holes ever get smaller. And the answer is yes, in a strange and quiet way. A physicist named Stephen Hawking, one of the most celebrated scientists of the 20th century, a man who thought about black holes more than almost anyone, worked out that black holes very, very slowly lose a tiny, tiny amount of energy. This energy escapes as a kind of faint radiation. So faint, it has never been directly detected because it would be impossibly hard to measure. But the mathematics says it is there. And over an extraordinary length of time, longer than the current age of the universe, many, many, many times longer, a black hole would, very slowly, get smaller and smaller. Like a piece of ice left out on a very cold day, barely melting, but melting all the same. And eventually, after a time so long that it barely means anything to say the number, a black hole would be gone. This is called Hawking radiation, after Stephen Hawking. And it means that black holes, for all their enormous permanence, are not truly forever. Given enough time, much, much more time than we usually think about, they too, eventually, quietly fade. Everything, given enough time, becomes quiet. The universe is very old. 13.8 billion years, as best as we can currently measure. And in that time, many, many stars have burned and collapsed and become black holes. There may be hundreds of millions of black holes in our galaxy alone. Scattered through the Milky Way, quiet and dark, drawing in whatever comes close enough, waiting. And far beyond our galaxy. Because our galaxy is just one galaxy among hundreds of billions. There are hundreds of billions more. Each one likely with a supermassive black hole at its center. Each one with its own scattering of smaller ones throughout. The universe is full of black holes. Full of these places where light cannot go, where time moves strangely, where matter is pressed together so tightly it becomes something almost beyond imagining. And yet, from here, from your warm bed, in your room, on your planet, around your star, you cannot see them. They are invisible. They are the quiet dark between the bright things. The deep rest beneath all of the light. Our sun, by the way, will not become a black hole. It is too small for that. When our sun eventually runs low on fuel, and this is billions of years away, so there is absolutely nothing to think about tonight. It will puff up into something called a red giant, very large and very red, and then slowly shrink down into something called a white dwarf. A small, quiet, cooling remnant. Not a black hole, just a gentle dimming. More like going to sleep than anything else. The stars that become black holes are the very large ones, the heavy ones, the ones that burned so hot and so bright for so long. They are the ones that end dramatically in an explosion called a supernova, before their core collapses inward. Our sun will go quietly. Ours is a calm star, patient and steady, warming the same patch of space it has always warmed, turning slowly through the same old cycles, year after year, for billions more years to come. We are very lucky to have such a calm star. There is one more thing to say about black holes before we let them rest for tonight. They are new to us. New in the sense of known, measured, understood. But they are not new in themselves. Sagittarius. Ak, sitting at the center of our galaxy, has been there for many billions of years. It was there long before there were any people to look for it. It was there before the Earth existed. It was there before our sun was born. All of that time, it waited quietly at the center of the Milky Way, doing what it does, completely indifferent to whether anyone was watching. The stars went around it. The galaxy turned, slowly, like an enormous pinwheel, once every 250 million years. And the black hole at the center sat still, and was dark, and was patient. And then, eventually, after all of that time, small creatures appeared on a small blue planet circling a small quiet star in a distant corner of the galaxy. And those small creatures looked up at the sky and wondered what was there. And they built instruments and did mathematics and thought very hard for centuries. And in 2019, those small creatures took a picture. And there it was, sitting in the center, as it had always been. A ring of warm orange light and a deep dark quiet in the middle. We looked at something that had been waiting for us for billions of years. And it was exactly where the mathematics said it would be. Now the universe is very quiet tonight. The stars are doing what stars do, burning slowly, warming their little patches of space, casting their light across the dark. The black holes are doing what black holes do, sitting still, pulling gently, being patient. And you are doing what you do. Lying quietly, letting the thoughts slow down, letting the day drift away. There are things in the universe that are very fast. Light travels fast. Quasars blaze bright. Supernovae explode in an instant across the sky. But most of the universe moves slowly. Galaxies turn slowly. Black holes wait quietly. Stars burn for billions of years. Most of the universe is patient. And maybe that is something to carry with you into sleep. That patience, that stillness. That sense of enormous quiet things sitting gently in the dark, doing what they have always done, without hurry, without noise. The black hole at the center of our galaxy is 26,000 light-years away. It is not going anywhere. It will be there tomorrow, and the day after, and 1 billion years from Tuesday. It is very, very patient. And you can be patient too, right now. Patient and still and quiet, letting sleep come in its own time, letting the thoughts go soft. The universe is very large and very old and very quiet. And you are a small, warm, curious part of it. And it is time to rest now. The stars are out. The dark between them is deep and still and full of quiet things. The light from far away is traveling, as it always is, crossing the enormous distances, patient as anything. And somewhere in the quiet of space, at the center of the galaxy, the black hole waits. Dark and still and unimaginably patient, as it has always been, as it will always be. Good night, little one. Good night.